All right, let's take a look at what we have to start the year here. Let me put this up on the screen, and we will dig into our Algebra 3 course. All right, in Buzz, you have your Algebra 3 course. Of course, you should have already done this in academic integrity contract. We looked at it on Friday. If you weren't here Friday, didn't get that done, you fill out this, hit submit, and then you have to hit this button in the corner down here. Mark this activity complete. If you don't mark that, it still will not let you go on. So do this, mark this activity complete. All right. You have a pretest. There, I'm not going to go over the pretest. That's just to see what you remember from previous algebra classes. So that pretest you do whenever, but we're not going to cover that. I'm going to go over the Algebra 1 review, or the algebra review, which is Algebra 1, Algebra 2, Algebra 1 review lesson, and revisiting functions, because this is where it kind of gets pushing you on what you remember. So let's look at these real quickly, and then I'm going to do some examples with you. The algebra review lesson talks about how you got to have that block foundation. It says if you got a stack of blocks and you grab one of the ones at the bottom and you pull on it, suddenly you don't have a stack of blocks anymore because they all fall down. And that's what we're looking at as our foundation. We got to know our earlier algebra classes to be able to build on that and learn more. So, order of operations. Remember PEMDAS? Please excuse my dear Aunt Sally, or whatever you learn that to be. PEMDAS, parentheses are first, then exponents, then multiplication and division from left to right, then addition and subtraction. So, some examples here. I'm not going to go through all this because I'm going to actually work some examples with you. But here's some problem right here. 16 minus 4 plus 3 plus 10 divided by 2 times 5. What's the answer to that? Well, you got to choose order of operations. There's no parentheses. There's no exponents. So multiplication and division come first. So the first thing you would do would be divide 10 by 2. Oh, they're going to step you through it. See, 10 by 2 would be 5. So now you have this statement instead. So the next thing you do would be multiplication. 5 times 5. That'd be your next step. Because order of operations. Now everything's just addition, subtraction. So you just start at the left, go left to right. 16 minus 4 is 12. Then you take the 12 plus 3 is 15. And then 15 plus 5. So it all equals down. Where this equals 40. And so they have some more examples down here that you can go through. There's 4 screens there to show you how to step through that. Again, I'm not going to go through all that with you. You need to look at your lessons that are here in Buzz, but we're going to work some examples together. And remember, -2, this is an important note. If you have -2 in parentheses to the 4th power, that means it's -2 times -2 times -2 times -2, which would be 16. Because the -2 is inside of parentheses. If you just have this -2 to the 4th power, well, that would be the same as -1 times 2 to the 4th power. So 2 to the 4th power is 16 times -1. That answer would be -16. So the parentheses make a big deal, make a big difference. -2 to the 4th in parentheses is different than -2 to the 4th with no parentheses. And you can click there, get more information on order operations if you need some more clarification with that. This is review, so I'm not going to spend a lot of time, but you should go back and go through this. Solving one-step equations. All right, we'll hit this very briefly. Here are 6 examples with all having videos. X plus 4 equals -7. When you watch that video, it'll tell you it's 11 seconds. It'll tell you that. Oh, let me turn that volume. To the x plus 4 equals -7, you're going to subtract 4 from each side. So x would equal -11. So those are all one-step equations. Two-step equations mean you've got to do more than one thing. Like this, we have to move the 9 to the other side since it does not have an x. And then we'd have to divide both sides by 3. So you can hit that real quick. Get the 3x plus 9 equals 30. The first step that you would do would be to move anything that doesn't have an x to the other side of the equal sign. So they're moving that 9 over. So then you have 3x equals 21. And we don't want 3x, we want 1x. So we're going to divide by 3. So we divide both sides by 3. So that keeps the equation the same. 3x divided by 3 just equals x. And 21 divided by 3 will equal 7. So there's 2 examples of that if you need to review that. And like I said, 6 examples of a pair. And you can learn more on two-step equations if you need it right there with the click box. Again, this is review. I'm not going to spend a lot of time going through the lesson on that. Variables on both sides. You got to move all the x's to one side, move everything that's not an x to the other side. If you remember that. Literal equations. Now, this is worth looking at. If we have A equals L times W, which is area equals length times width. All right, that's A equals L times W. What if we needed to know the width? Can we rearrange that? Well, since length times width equals area, if we divide both sides by the length, divide by L on both sides, width equals area divided by length. Just looking at rearranging equations, literal equations. Area equals pi times radius squared. If we want to rearrange it for radius, we have to divide both sides by pi because there's a pi times radius squared. So area divided by pi equals radius squared. Since we just want radius, not radius squared, we take the square root of both sides. So the radius is the square root of the area divided by pi. All right, so can you rearrange equations? Again, here's the lesson summary. If you want to make notes of this review lesson, it goes through order of operations, solving one-step equations. There's 6 different examples right there. Solving two-step equations, and when variables are on both sides. So there's a nice summary. If you print that and keep that in the 3-ring binder if you want to, you can copy those into your notes. Remember, any notes you have can be used on tests and assignments. So like I said, I'm not going to spend a lot of time on the first one. It's the second one I want to get to, because that was just a review. But let's talk about revisiting functions. Revisiting functions. All right, so with a function, not every equation is a function. Equations versus functions. The mathematical term function applies to some equations, but not all equations have the requirements to be called a function. So here are some equations. X squared plus y squared equals 1. If you graph that, that's a circle. Right? X plus 7 equals 10. That's a linear equation, makes a line. Y equals 2x plus 3. That's a linear equation, it makes a line. This one here, the x plus 7 equals 10, actually makes a line that goes up and down. It's a vertical line. This is a slanted line with a slope of 2. Y equals x squared minus 7x plus 6. This is a quadratic equation, right? So it's going to graph a parabola. But are all of these functions? So let's start by looking at this linear equation that we're most familiar with. Y equals 2x plus 3. So in order for an equation to qualify as a function, there must be only one y value for each x value. So out of the 4 examples above, the 2 that meet this requirement are 2x plus 3, y equals 2 equals 3, and the quadratic equation. The other 2, the first 2 up there, do not meet the requirement, and we'll look at that. But when we look at the table you can make for this equation, where we choose an x, substitute that x into the equation, and determine what y is, for every x we put in there, we're going to get only one y value. And so they did from -2 to 2 using integers. You got -1, 1, 3, 5. They're all different. And there's only one. They could be the same. They could all be the same, but as long as there's only one y for each x, -2 only has one value. So that is a function. Let's look at the quadratic equation. 1y must only be 1y. So choose these x's, and they only have one y value right there, -2. Substitute -2 into there. -2 squared is 4. Minus 7 times -2, that's positive 14, plus 6. So that all equals 24. 4 plus 14 plus 6. Only one value. Now, these two, it said, did not meet the requirements of a function. Why not? Well, let's substitute -1 in there. Okay, well, it just has one value for that. It's 0. How about when we substitute a half? Well, if you substitute 1/2 in for x, the y could either be 3 square root of 3 over 2 or negative square root of 3 over 2. If we substitute 0, then it could be 1 and -1. Notice there are two different y values for some of the values of x. When you substitute 1, there's only one value, -1. But there are x's that have more than one y value, not a function. Let's look at the x plus 7 equals 10. That's subtract 7 from both sides, x equals 3. Well, see, there's all the y's. All the y's. Y equals 1, 2, 3, 4, 0, -1/2, 2/3. There's a whole bunch of different y's, the same x of 3. You make a table, the x's are, there's only one x is 3, and it has every single y. So that is not a function. So got a little matching activity to help us better understand functions. Select the word and then select the definition that you think matches it. So somebody take a guess in the chat. If we want to guess what year Twilight came out, what year was Twilight released in the movies? All these are a little older intentionally. Anyone have any idea how old Twilight is? 2005, 6, 7, or 8? There's two choices of 8. Nobody wants to take a stab at that one? All right, 2006. Let's take a guess. Twilight, 2006. Oh, it is not 2006. Let's try another one. All right, let's try. Since there's 2 8s, let's try 2 8s. Nope, it's not 8. We've eliminated that now. It's either got to be 5 or 7. Let's go 7. Oh, it's wrong. The last one, of course. Oh, it says they're all incorrect. Wait a minute. Am I supposed to drag these around? Maybe it's the other 2008. See, now that their thing is wrong. See, it only lets me choose one of the 2008s. All right, now I'll be simpler. Madagascar. Those of you who like that movie, it's a pretty funny movie. Any guesses? What do we want to guess for Madagascar? Throw a date out there. All right, 07. Oh, it was not 07. How about, is it newer than that? 08? Nope. Okay, let's try 05. It was 05. Good job, Michaela. Okay, the original Pirates of the Caribbean Dead Man's Chest. Let's see. We got 6, 7, and 8. Let's see if it came out in 8. No, it did not. It's got to be 6 or 7. Well, of course, I chose all the wrong ones. 2006. So The Dark Knight and Enchanted came out in 2007, 2008. So we're going to say The Dark Knight came out before Enchanted, but it did not. Dark Knight was 2008, Enchanted 2007. Okay, we're not going to restart that. So if we look at that, notice that each movie only matched to 1 year, right? So this is a function. Every X only had 1 year. Every movie only had 1 year. It's okay that there were 2 movies that both came out in 2008. That's fine. But each movie only had one value that it came out. See, it wouldn't make sense when the movie was released in 2 different years. Like if Madagascar was released in 2005 and 2007, that would be weird. because it wouldn't do well in 2007 because everybody wanted to go see it. So in 2005, there'd be some people in 2007, but you don't release a movie in 2 different years. Now you may release like an anniversary edition of a movie, but that's a new release technically. So they release a movie as 1 year that it was released. If we went the other way around and we said, okay, for what year, what movies were released, that would not be a function because 2008 has 2 different answers. So it's only a function if we look at the movies in relation to the year, not the year in relation to the movie. It only works one way. Movie, then year. All right, so that's looking at functions. If we have a graph, if you graph a function, then you have what you call the vertical line test to see, is this a function? So if you have a function that you're struggling with and you're trying to figure out, all right, I don't know, I have this equation, I think it's a function, but I'm not sure. Graph it. Go to desmos.com, throw it on a graph, give it the vertical line test. If a vertical line can be drawn through any point on the graph without it touching more than one point, it's a function. So let's look at this. We have these points. Okay, we don't have the line, we just have points. Maybe from a table, we graphed them. So if we look at it, we say, well, if it was a line, it'd be just like that. So let's make a vertical line. See, the red line is a vertical line. When we draw that vertical line, it only touched the graph in one place, way down at -7. Well, let's move it. If we move to the right, it still only touches in one place. Anywhere along that we move that vertical line, it's only going to touch that graph in one point. Only in one point. So that means it is a function. Okay, let's look at this. Let's determine which of these is a function and which one's not. Is this a function, given the vertical line test? You put yes or no in the chat. Is this a function? If we draw a vertical line, will it touch this more than once? Michaela says, yes, this is a function. Let's click. It's not letting me click. Oh, it's not staying clicked. Great job. That was the correct answer. How about this? Is this a function?
It is important, especially in this class, that you always look at this.
Oh, nobody's sure. Michaela says no. Anyone else think it's a function? We draw a vertical line, let's say where x equals 2. It's going to touch the graph up at 4 and touch the graph at -4. There are 2 different points. Non-function. That's correct. How about this? Courtesy of Texas Instruments. Function? Function, Carmine says. Yes, that is a function. Only one place will it touch. This? No, not a function. Great job. We'll have it a circle. Is a circle a function? No, of course not. It'll touch in many places. It touched 2 places. It decided to only touch one place. There's only 2 places you can do that. Not a function. Our last one. How about this? This is like an x to the third. X to the third type equation. But yes, it's a function because it's still only going to touch in one place. All right, you guys got the idea of functions with graphing especially. All right, function notation. All right, let's talk about function notation. F of x is the same thing as y. We say y equals, but if we write it in function notation, we say f of x equals. And that's how you pronounce that, f of x, f of x. Okay, so that replaces the y variable. But it means the same thing. So if we take f of x and we substitute -6 in for x, 2 times -6 is -12 plus 3 is -9. That is, if we put it on the graph, when x equals -6, the y would equal -9. So the f of -6 equals -9. It's the same thing as y equals. It's just written in function notation. So here's more. If you need to know more about function notation, here's some extra notes on that you can click on, and it goes through another example for you. Domain and range is also discussed here because we talk about domain and range. Domain's all the possible x's, range is all the possible y's. So that you can review those notes at your leisure as well. Here's where it gets a little tricky sometimes. Inverses of functions, because we don't spend a whole lot of time on that in Algebra 2, but we do cover that. Now, do you remember inverses of functions? Because here in Algebra 3, we're going to use inverses from time to time, so I need to make sure you remember that from Algebra 2. An inverted roller coaster is a ride where the cars run underneath the track instead of above it. I've ridden in some inverted roller coasters. It's cool where the track is above you and you're hanging underneath it. Those are fun. Of course, I also think it's fun to have the regular roller coasters. I like all the roller coasters, except the wooden ones. An inverted airplane is one that's flying upside down. Inverting the colors of a photograph will turn colors to black and black colors to white and white colors to black. So inverting something is the process of reversing the order or reversing the position of something. So to find the inverse of an integer means you would perform an operation that would cancel out the number. So for the number 7, you could add -7, and that would cancel it out. Now you have nothing. Or you can multiply 7 by 1/7, cancel that out, and just have 1. So in multiplying, you do a reciprocal. So with equations and consequently functions, finding the inverse requires reversing the variables. So let's see. Rather than going through the examples here on the page, I'm going to move this over here. Put this up instead. Yes, that's my Weird Al wallpaper there. Because I had backstage passes to see him in person last year with my son-in-law. All right, let's work through some of this together. So if we're going to find the inverse, okay, let's start with what they had. F of x equals 3x minus 5. And this is the example from Buzz. So if you don't remember this, you can watch the video on Buzz later or watch this in Google Classroom. So there's a few steps. Okay, step 1. F of x becomes y. So the first thing we do is we change this back to our regular notation, take it out of function notation and put it back as a y. So the first thing we do is we take the f of x out. You can write that in your notes however you want to. I'm just writing this notation here. Make sure you have it where you understand the steps. Step 2, swap x and y. I'm going to swap those. So x equals 3y minus 5. See, I just took the x and I moved it over to where the y was, and I took the y and moved it over to where the x was. I just swapped them places. Step 3, solve for y. We want to get it back to y equals, just like it was here. But now we're going to solve this for y. So this goes back to solving equations. This doesn't have a y, so let's move it to the other side. That's an x. This is not an x, so those don't go together. They're separate terms, x plus 5. And this side is 3y.
Yeah, so he's in there. Let me make sure.
We're not to y yet. We're at 3y. So let's divide by 3. So y equals x plus 5 divided by 3. So this is the inverse of this. 3x minus 5, x plus 5 divided by 3. In function notation, we write that this way. We put this a little apostrophe up there, and this means inverse function. So the inverse function is x plus 5 divided by 3. You can write this as x over 3 plus 5 over 3. That's the same thing. These are equal to each other. Same thing. Equal. Okay, that's the same thing. So let me write that. Looks like an 11 when I do it that way. So those are equal. That's the same thing. But this is generally the way we'd write that. That's the simplified version rather than breaking it apart. But they do equal the same thing. So function notation, inverses. All right, so there you go for your notes. Inverses right there. So let's play a little bit with that. Now that we know the steps, solving inverses. Let's choose one that's a little trickier. Let me see here. I know they have some other examples. What if we want to find the inverses f of x equals x squared? Okay, f of x equals x squared. Okay, so this is the function, right? It makes a parabola. You know, when we graph that, that's an x squared. It's a parabola. So let's find the inverse of this. Y equals x squared. So we rewrote it as y equals. Now we swap them. X equals y squared instead of y equals x squared. And now we solve for y. We have y squared, so we want to take the square root of both sides. Square root of x equals the square root of y squared. The square root of y squared is just y. Square root of x is just x. So this is the inverse. This is not a function, because if we graph the square root of x, it ends up with something that is not a function, because it actually just turns the parabola sideways, kind of like that. And when you do the vertical line test, it fails. So there is an inverse to this function, but its inverse is not a function. Inverse is not a function. But it does have an inverse. Inverse, check. But the inverse is not a function. But it doesn't mean it doesn't have an inverse. So being able to find inverses is part of what we need to know how to do. Let's see. What else do we need to review here? Oh, yes, this is covered in this lesson. So you go back to this lesson. Composition of functions. So if we have two functions, let's see, I'm going to use the one from the book. Yeah, I'll use the one from our curriculum. So if f of x equals x plus 1500, and we have a g of x, and it equals 3x. We have two different functions, right? So now they want us to find g of f of x. You're like, say what? G of f of x. That means take f of x and substitute it into g. Whatever's inside this parentheses gets substituted in to g, right? Into g. So this gets substituted in for the x. So instead of x, this will be 3 times. Instead of x, I got to put f of x in there. Whatever used to be x is now x plus 1500. See, because that's what f of x equals. And so now that equals, get rid of the parentheses, 3x plus 4500. That's what g of f of x equals. Because we just substitute what's inside the parentheses into the equation, and we get that. So taking that a step further, I mean, when we think about it in function notation, a lot of times if we have f of x equals x squared minus 1, we say, okay, what is f of 3? It's the same thing. We're just taking whatever's inside there and substituting it in for x. So we're saying, well, instead of x, I'm putting 3 because I changed that to a 3. 3 squared minus 1, which is 9 minus 1, 8. So f of 3 is 8. Right? So in our previous example, when we just took f of x and substituted in, it might ask us, it might take that a step farther and say, instead of g of f of x, find g of f of 1,000. Like, whoa. Well, now you've complicated it even more. So there's two ways you can do that. You actually have options on this. You could do this first. Substitute 1,000 into the f of x. Say x plus 1,500, 1,000 plus 15, that's 2,500. So you could say, okay, g of, well, f of 1,000 we know is 2,500. We can say just g of 2,500 because that's what f of 1,000 equals. So that would be 3 times 2,500 or 7,500. The other option you have is you know what g of f of x is. It's this. Right? Ooh, are we going to get the same answer there? Yeah, we'll get the same answer. So 3x, whatever x is, we're going to substitute 1,000 into. G of f of x, 3 times 1,000 plus 4,500. That equals 3,000 plus 4,500. It's 7,500. You get the same answer either way, whether you want to substitute it into the f first and find out what that value is, or just take g of f of x and instead of x, make it 1,000. So composition of functions. Can you substitute one into another? Can you substitute? Can you go either way? Let's do another example back here. Let's say, and I'm going to make this one up. I'm not going to use one from Buzz this time. F of x equals x squared, and g of x equals 2x minus 1. So we can do f of g of x, or maybe we need to do g of f of x. Are those the same? Well, let's see. Substituting g of x into the x, or substituting f of x into the g's x. So let's do both of those. So if I take g of x, right? So whatever's inside there is getting substituted for the x. So that means instead of x, it's 2x minus 1, because that's what g of x is, 2x minus 1 squared. That's what g of x is, 2x minus 1. So it replaces the x, and it's squared. Over here, I'm taking f of x, and I'm substituting it in. So x squared minus 1. We can get rid of that parentheses. So that's the same as 2x squared minus 1. Is that the same as this? No, because this is 2x minus 1 times 2x minus 1, right? Because it's squared. It's squared outside. So this is 4x squared minus 4x plus 1 when we multiply those together. So this equals this, this equals this. It's different depending on whether we're substituting g of x into f or f of x into g. But those are compositions of functions. If we said f of g of -1. That would be different than g of f of -1. Because this one we would take -1 and put in this equation. Or we can put it up here first if we want. But I mean, you know. But 4 times -1 squared is +1. So 4 -1 times -4 is +4. 4 plus 4 plus 1, so that would be 9. Over here, -1 squared is 2. 2 minus 1 is 1. And again, you can substitute the -1 there first. Be -2 minus 1 is -3. And then put it in f. -3 squared is 9. So it'll work either way. Let's see. Let me put this back up here. So that's what they're doing in their examples, is they're looking at finding if this is f of x, 7x, and g of x is 3x plus 10, find those. And tells you how to do that. Substitute from one to the other. So the function g of x is inside the function f of x. So they put it inside the f of x. So it'd be 7x, 7 times 3x plus 10, because we're substituting the g of x in there. And then simplify it, where you get rid of the parentheses, 21x plus 70. So they have a few examples here. And then the lesson summary. But they have some more. There's the inverse. Those are the steps for that. And they put a fourth step where you put it back in function notation. I did that on my paper. I just didn't write this as a step. Make it back to function notation. So, all right. So there is the lesson summary. Again, you can have in your notes for tests and everything. This summarizes everything we learned. There are more examples here. And then there's a page of practice problems. You try. So gives you f of x right there. And it says, okay, what is f of -5? What is f of -3? What is f of 0? Substitute those in there. So if you think, let's see, match it. I can drag and say, this one's 7. So I can just match the answer to whichever one I believe it is. Right? Like if I think this is -9, I'll match it over there. So it gives you, and then it's got, you try to more for you to try. Find the inverse of this here, 2x minus 11. Go through those 4 steps, and then you can check your work. You turn that, and it'll tell you if you're correct. So make sure you're doing these practice problems in the lesson before you're doing the actual assignment, so you know that you understand it, so you know that you can get these right, because it will give you practice problems in the assignment, so you can go through it and make sure that you understand what you're doing. So, okay. Take the pretest sometime just to see what you know for this unit. But this is what your grades are this week, 1.01, 1.02. When you go to your grade screen, you can see what's due this week. So the pretest is due, but it doesn't count in your final grade or anything. It's just a pretest. Review 1.01, 1.02. There's what's due Sunday. All right. Friday is an A day. We did 2 A days in a row. So we're doing last Friday and this Friday it's an A day. So I will be in class on Wednesday and Friday. If you need help, come on. Right now, no one has a grade less than 70, so no one's required to be here Wednesday or Friday because we don't have any grades in yet that count. So you don't have a grade less than 70. So you're not required to be here Wednesday and Friday, but I will be here. Now, I won't stay the entire class if nobody's here. So, don't come in here at 10:20 and say, well, I came to class, but you weren't there. Well, yeah, there was like 5 minutes left of class. No one was here. I left. But I will be in class. So if you have some questions, got some problems, you can email me or you can come to class Wednesday or Friday and we'll see you then. So otherwise, next week is Labor Day. So we are going to end up meeting on Wednesday next week instead of Monday because there's no school on Monday. It's Labor Day. So I'll see you guys next week on Wednesday. Have a great week.